Okay, here we are, the end of week 2. I'm going to hand the rest of these back while you're doing the in-class assignment. So while you're doing it, I'm going to listen for your name while you're working on the in-class assignment. We're on, from 17th is where we're at. The end of week 2. Week 3 is going to be this Thursday and next Tuesday. And then Thursday, a week and a half from today, is your first quiz. I'm going to keep reminding you so you don't forget what's going on. So, let's see, before we get into that, I didn't get a chance to go over anything finance, but I did look these up real quick. Crude is at $80.85 according to Yahoo Finance. Is this higher or lower than it's been the last couple times we talked about it? I think it's a little higher, I'm not sure. And then these prices are the 3 lowest prices in the same zip code I keep looking, 311, 315, 317. So this is also a little higher. So what I'm trying to point out is, as we keep track of this, the question is there a correlation? Is there a relationship between crude oil price per gallon, I think, or per barrel, or whatever that is, and gas prices? And I'm making the claim that this is a leading indicator that this predicts what future gas prices will be. So if that's at 80 today, and these gas prices are based on what crude was Friday, or whatever the last trading day was, or Monday, excuse me, which crude was in other parts of the world, were traded yesterday. So whatever it was, if it's gone up, these are reflecting what crude was before this, the last trading day, or a couple days ago actually, is what I'm saying. We'll see if it comes true. That brings us to this correlation, which we're going to talk about today. We're trying to determine if there is a correlation between these, some kind of correlation. So, now, I want to review, no, you know what? I know there's some people are probably going to be a little late, so I brought something up I want to bring to your attention. Or maybe I'll wait till the end. Let's keep going. I want to do a little review then. I'll bring it up on the end. Here we are, this should look familiar. I put these percentages right here. These are the given percentages when it comes to the empirical rule. 100% is all the area underneath the bell curve. 50% is the area to the left of the mean, or the area to the right of the mean underneath the bell curve. Even though my drawing sucks, these are supposed to be the exact same area on each side. All right? Then, the empirical rule says 68.26% is between 1 standard deviation above, 1 standard deviation below. 95.44% is at 2 standard deviations above, all the way to minus 2 standard deviations below. And then 99.72% of the area underneath the bell curve is in 3 standard deviations. You're about to do an assignment where you're asked to use only these given numbers to estimate then what percent of the bell curve is at a certain point on this line to either the left or to the right in your homework assignment. That homework assignment, let me bring it up. Is this it? By the way, there's 3 homework assignments. Number line assignment, written assignment, Excel assignment. So we're talking about the number line assignment right now. And in this number line assignment, it says, draw a number line with a bell curve drawn above it. Show work calculating and placing the usual 7 numbers underneath the number line. The mean would be in the number, middle, 3 numbers to the left, 3 numbers to the right. The mean is equal to 62.5 and the standard deviation is 8.6. So on this assignment, I'm expecting you to draw something like this, put those numbers right here, obviously the mean's right there, and show your work. Show what you're adding and what you're adding to get the next number. What are you adding to get to the next number? What are you adding to get to the next one? And same the other way, just like you did on last week's homework. Show that work. But now it says you're going to do a shading from a certain point. If the space underneath the bell curve to the number line represents 100%, there's given. All of that space is 100% from this line underneath that curve. 50% on each side of the mean. That's also given. What would you estimate the percent of shaded space area from the number 71.1 and to the left? So somewhere on this number line, you have to figure out where 71.1 is, draw a little, maybe a dotted line or something, and shade to the left. I don't know if it's here, 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 I don't know where it's at. Since the mean is 62.5, I'm gonna guess it's larger than the mean, so it's probably over here somewhere. You're gonna draw a little dotted line and shade. That's part of your answer you have to hand in. Show me that curve, bell curve, based on that question. Then you shaded it in, and then it says, shaded from 71.1 to the left, use the empirical rule to guide you on page 110, or from your chapter 3 PowerPoint slide 35, show your detailed calculations. And what I mean by that is, to come up with how much of this area is to the left, I expect you to use these numbers to start with. And then either you're using algebra from that point on, but you must somehow, and I want to tell you, that first question, I would say there's at least 10 different ways to answer it. 10 different ways, so everybody could have, could have a different answer. I'm sure there's even more than 10. But all of you need to start with these numbers, 1 or 2 of these or whatever you need to answer that. One person may say, okay, I don't know where that number's at. Let's pretend like that number is, let's pretend it's right here. No, we said it's above it, so let's pretend it's right here, 3 above. Let's pretend it landed right there on that dash. How would we get that number? One person may say, well, I'm gonna figure out what that little tail is and subtract it from 100%. That's one way of doing it. Someone else may say, I'm gonna figure out what it is from the mean to the 3 and then add it to 50%, because we know 50% from there over, I just gotta figure out this area. Someone else may say, I'm gonna do this and subtract this. Someone else may say, I'm gonna do it this way. There are so many ways to do this, but I expect in the work that you're showing me you came to your conclusion starting with these numbers. Whether you're dividing them in half, whether you're dividing them by 4, however you're using these numbers to come up with the answers for number 1 and then again for number 2. But number 2, you do not have to draw a number line again. Number 2, you're supposed to just imagine the number line and a shaded area. From what point? Do not draw a number line, but if you were asked hypothetically to shade under the bell curve from 45.3, that number is less than the mean, so somewhere over here, you're supposed to imagine a number that's somewhere over here to the left. Does it say to the left? From 45.3 and to the left. What would you estimate the shaded area to be out of 100% and show your detailed work? Again, start with these numbers. And if you already showed work doing number 1 and you found other numbers because maybe you divided that in half or maybe you divided that in half, you don't have to show that work again. Just put some arrows up and say, I got this number because I did it for number 1 or something, just put an arrow. I'm just looking for you though to start with these numbers and do algebra to answer those 2 questions. What's the area from a certain spot here to the left? What's the area from a certain spot here to the left? That's number 1, and that one over here is number 2. Any questions how to do this number line assignment? Does everybody understand what's expected of them? Everybody does? It seems easy? Okay, all right. And there's a lot of different ways to do it, so I don't expect everybody to have the exact same answer, so please don't have the exact same answer. All right, that's your review for that. What do we want to talk about now? Let's get to the hard stuff, I guess. Going to switch to slide 24, same PowerPoint in case you opened it. Oh wait, slide 24. Review range. Now I remember why I want to review the range. Anybody remember if we had, remember those 70 pieces of data with all the different rents and we put them in order from smallest to largest? How do you find the range? Here we go. Okay, I want to repeat that for everybody. She said, find the smallest number, find the largest number, and when you put them in order, it's going to be the top left and the bottom right, right? Or right? And then do what?
Divide.
No, not divide them.
Well, add them.
No, not add them. Subtract them. But I give you full credit for getting this in. Subtract them. The largest minus the smallest is the range. But now we need to do it using Excel. And I think I forgot to open that spreadsheet. So let me look. Did I? Yes, I did. Hang on. Hang on. maybe edit this out? Is that possible? Thank you. What happened? Didn't open? Oh, just opened it twice. Okay, here's your Excel function equations for the day. Today we're learning how to do max and min. What this does is Excel will go and look at the data and it will find the largest number for you. Or Excel will go and look at the data and find the smallest number for you. Max, M-A-X, parentheses, give the location. So you gotta give me that equal sign in front, then the M-A-X, then the parentheses, and then the cell where the beginning of the data is, dot dot, which is a colon, then the cell location where the end of the data is. In this case, the data is at B8 through B25. Let me look at the data, I gotta scroll down here. B25 even includes letters. Look at that, A, B, and C, D, E down here. But it doesn't matter. Excel knows that when you're using the word max, it knows to only look for the largest number. It will ignore those letters. And it brings back 232. Can someone confirm? It looks like that's the largest number. You agree? Anyone agree? Yes? Okay. Min, M-I-N, parentheses, B8 through B25. It's going to look through all that data, including those letters, and bring back the smallest number. So in this case, it's a 1. And then all I'm doing here is I'm showing you how to find the range of data using these new Excel functions you just learned, even though many of you probably already knew both of these. But for this class, it's new, taking the max minus the min. You have an assignment, and in that Excel part of the assignment, you need to give the equation to find the range of the data. This is almost exactly what you're writing down, except the cell locations will be different, because the data won't be in B8 through B25. But it's the max minus the min. That's how you answer the Excel. Let me show you the Excel homework. Boy, I'm making this homework too easy, but I'm just going step by step. I might as well just do it for you. I don't understand what's going on. Right there's 1. You're going to put the Excel functions to tell the range of this data up here above. Even though it's obvious, don't go equals cell wherever the largest. E17 minus E9. No. This is about showing me you can use max and min. It's not showing me you can find the range out of what 6 numbers there. I mean, my grandmother could do that. It's showing me you can use max or min. That's what this is about. Now over here, you're showing me you can do it again. That's all. Does everybody get this part of the homework? Yeah. Any questions? Thank you. All right. That was the easy part. There's range. Now, let's get to variance. Variance. Let me get to the equation. Let me start by telling you there's 2 equations up there, but for this class, we're going to focus on the sample equation because everything done in 302 is sampling, and I want to prepare you for that, so we're going to have most of our problems be all about sampling more than the population. So which 2 of these equations, what's the difference between these 2 equations? Does anybody see what the difference is? What is it? Anybody? Go ahead.
You have to subtract 1.
Yeah. In the denominator, you got to subtract 1 from n. N is the number of pieces of data you have all together, and you got to subtract 1 from it before you divide. That's the difference, and that's the one we're using on your homework. That's the one we would use on the quiz. That's the one we would use on the final exam. Sample data. Don't get me wrong, you need to know about population. We just wouldn't subtract 1. But you'll see in the words of the homework when you open up, it says the following data is sample data. So you now know which one to use. And a matter of fact, let me show you this homework. Written assignment says, find the variance and standard deviation manually for the 6, and I highlight the word sample. Sample in bold there. Pieces of data. Calculate the variance standard deviation, showing your detailed work. Okay, so there, now you know what the homework is, but let's learn how to do it. Here is the formula right there. And it looks like a tough formula. That symbol right there, right above my pointer, stands for the sum of. It means you're going to be adding, at the end of all this calculating, before you divide, your last step is to add everything. The first step is in the parentheses. See where it says x of I, or is that an I or a j? I don't know. X of I minus x, is that I or j? Is it an I? Okay. I just means data number 1, now data number 2, now data number 3, until you get to however many pieces of data you have. So each piece of data minus the X with the line over it is the mean. So let me start there. The first step to find the variance of data is you gotta find that mean, which means you gotta add up all the data divided by however many pieces of data you have. There it is. You gotta find that average, mean. That's step number 1. Number 2, subtract that number you just calculated from each piece of data individually, one at a time. Let's say the mean is 5. The first piece of data is 7. 7 minus 5. 6 minus 5. 7 again minus 5. 8 minus 5. 2 minus 5. 3 minus 5. Each piece of data minus the mean is in the parentheses. That's the second step. Third step. Every one of those subtractions you just did, you now got to square them. See how it has the square on the outside of the parentheses? One at a time. I know I'm going fast, but don't worry. Look at this example I posted. There's the data in column 1. Column 2 is the mean of that data. Notice you got the same number going in column 2. See how it's the exact same number all the way down? This is what I would use as my guide when I'm doing that homework assignment. And I want to tell you, in real life, this is exactly how I did it. I formed the columns. It just made it so much easier to take that formula, break it down, and make it into something really easy. So there's the raw data on the left. How many pieces of data we have? Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Anybody confirm? Did you say 12? Oh yeah, look, we're dividing by 11 at the bottom, n minus 1, so there must be 12 pieces of data for us to be divided by 11. So 12 pieces of data there. If we added all 12 and divide by 12, we get 3540, 3,540. There's step 1, get that mean. Step 2, subtract the mean from each piece of data individually. Look at column 3. That first piece of data, 3,450 minus 3,540. Minus 90, going straight across, negative 90, because the X is a lot smaller than the mean. Now do the second one, 3,550 minus 3,540, 10. And you keep doing that for all 12 pieces of data. You're subtracting the mean from each one. See my column right here? I'm making up numbers, just off the top of my, matter of fact, throw some numbers at me.
2,
11, 2,
3,
8, one more.
10,
15. There we go. What's the mean? Someone help me out. I'm going to go in my head real quick. 8, 9, 10, 21, 31, 36. 36 divided by 4, 9? Help me. 9? That is pure luck that we got a 9. It is never ends up being a 9. It would be like something point something. That was unbelievable luck there, you guys. So now this makes this easy. I'm finding the variance. I'm taking that formula, this whole top numerator of the formula, sum of x minus the mean squared. And I'm just taking it one step at a time for each piece of data until I get to this last column. Once I get to this last column, the big deal is you add it up. That's the part, the sum of. You get to the end and you add it all up. So let's keep going. 11 minus 9, 2. 2 minus 9, negative 7. 8 minus 9, negative 1. 15 minus 9, 6. 6. Now, the whole point of squaring it is to get rid of the negatives. That's really the main point. So the next step, all negatives should be gone. Everybody remember that. This next step, all negatives should be gone. 2 squared, 4. Negative 7 squared. What did I do wrong? I thought I heard somebody. No? Okay, let's keep going. Negative 7 wrong, 49. Negative 1 squared. Whoop, negative 7 squared. Negative 1 squared is 1. 6 squared, 36. Let's go back to this formula. Oh, there it is at the bottom. The sum of x sub I minus the mean of x squared. We just did that. Each one of the x's minus the mean of x squared, this column. We just finished that. And now the last step for the numerator, the sum of. Sum of means you add this last column up. 49, 50, 86. Oh, how lucky is that? 90. There's our numerator for this piece of data. There is a quiz question right there, showing me you can manually come up with that numerator so far. There's a lot of points right there. What am I dividing by in this example on the board? This sample data here, what am I dividing by?
3.
Exactly. Everybody hear that? Key word she heard was sample data. And there was 4 pieces of data there, so 4 minus 1 means I'm dividing by 3. 90 divided by 4 minus 1 equals, I can't believe this is turning out to be with no point something. Can't believe we didn't need a calculator for this. This is a first. Let's just dwell on it for a minute. Wow. How lucky. 90 divided by 3 is 30. We just found the variance. Now let's look at our example up here so you can see, before we get to the last step, we're not done yet. That's the variance. We took each piece of data, subtracted the mean, there's all the subtractions. Notice how those subtractions add up to 0. If you do this right, all the subtractions with the negatives and the positives will add up to 0 every time. So that's a little hint to know you did it right or not. Now square each one to get rid of the negatives. There's that last column. Every one of those numbers are squared. And then add them up. There's the sum up. That's our numerator right there, which we just did here. That's the sum of all those squares. Then the last step is you divide by however many pieces of data you have, minus 1. In this case, we had 4 minus 1, which is 3, which takes us to 30. In this case, it's 301,850 divided by 11, which took us to 27,440. What does this mean? It means the data, the raw data varies squared, though it's squared, but it varies, that's why the number's not making sense right now, about 27,440 if it were squared. What we need to know, though, is really how much the data varies by, and that's called the standard deviation. To get to the standard deviation, all you have to do is square root the variance. That's the last step. Everybody hear it? The last step is to go from the variance to the standard deviation by square rooting the variance. The square root of 30, I do not know off the top of my head. So someone's got to help me here. Say it again.
500.
No, square root.
I'm
Yeah,
sorry.
yeah,
I'm
yeah.
sorry.
30 times 30. Yeah. Square root it for me. Somebody, 9 times 9, 8 times 5 times 5 is 25, so 5 point something. 5.4772. 5.4772. What's that next digit, just so I know I'm rounding?
2.
Perfect, thank you. There you go. This is the standard deviation. And manually, you can't get to the standard deviation without getting to the variance first. You can't do the variance unless you figure out that numerator and then divide by n minus 1 if it's sample data, which in this case it was. And it will be on your homework also.
And the quiz formula.
No, the formula's not going to be given to you. The question is going to be like this, and it's going to say it's sample data, but you got to, in your notes or in your, whatever it is, you download it off Canvas, you got to find the formula yourself. It's in the book too, by the way. The formula's in the book. Now, I wrote the page down, I think it's 106. It's either 106 or 105 is the page number for this formula. Yes?
Will we have every piece of data, or will we have to find it?
No, if I were asking a question like this, I would give you every one of these, 11, 2, 8, and 15, and you take it from there. You're gonna have to find the mean then, you gotta subtract the mean, somewhere like that. Thought I saw one more question, no? Okay. We can all do the variance right now?
So the slides are not gonna have the equations?
No, you can have the PowerPoint open while you're doing the quiz though. And there's the equation right there.
They don't show up on the slides. Oh, I think I got that.
Oh, here's what's going on with the PowerPoints, you guys. I almost forgot. Wow, thank you for bringing it up. You can't open the PowerPoints in Canvas. There's something about it. Some of them will work and some won't. You have to download the PowerPoint, then open it up, and all these equations show up. Wow, forgot to tell you that. Is that what you were asking, someone else was asking about, and I didn't realize that was the question?
So if you have to use the added for calculation, how the question would be just,
Oh, well, the question would say, the following are sample data, 11, 2, 8, and 15. Manually calculate the variance and the standard deviation showing your detailed work. And you're just doing it just like this, right here.
and
Exactly.
that's for sample, it's n-1.
That's for the one on the left-hand side, n minus 1. How many pieces of data do we have here? I gave you 1, 2, 3, 4, and in this example, you were given, whoops, And on this example, you were given 12 pieces of data, so you have to know to subtract 1, then divide by 11, or subtract 1, divide by 3 in this case. And it will say sample data on the quiz. I'm not going to trick you and say, oh, this is population. Or else n represents then all 12, if it were population. So you know to subtract 1, because I'm not going to trick you. This whole semester, we're talking sample data. Okay?
So will we use that standard deviation for like if we're doing the
Yeah.
line?
Yeah. She's saying, hey, could we make this bell curve now? And the answer is yes. Look, 9 is our mean. 9 goes right in the center. Now we would add 5.4772. There's that one. Then we add another 5.4772. Add another. We just found the numbers to be able to form the bell curve based on this data. The problem with this data is it is large variation. The data is spread out because to have a mean of only 9 and a standard deviation of 5.477, that means the data is pretty wide from each other. And as you can see, look at only 4 pieces of data, and we're going all the way from a 2 to a 15. So that is pretty spread out. So that makes sense.
Will we use the population equation or just the sample?
You need to know the population equation, but as far as the quiz is concerned and the homework, it's all going to always be the sample. Be the sample. So you pretty much know if this question is being asked on a quiz, yes, I'm putting the word pretty bold there, sample, but you know it's going to be n minus 1 in the denominator. You should pretty much assume that. Okay? We can all do this, right, on the homework. You want me to show you that homework problem again, just to make sure we're all on the same page? Let me ask you this. What would you be dividing by? I can't believe I'm going to give this away. What would you be dividing by if you're finding the variance on this homework assignment?
5.
Yeah, I mean, it's too easy, isn't it? But show me how you get 5. Put on there, 6 minus 1 equals 5, so I know where you got the 5 from. That's what you're doing in your head. Put on the paper. So you now know how to do. The number line assignment. Right there, we talked about it, and you know these numbers are the big deal, right? And there's 2 of those questions. You now know how to do the written assignment. 1 set of numbers, there's 6 of them. Show me your manual work. It's up to you if you want to set up columns like this, that's up to you. Show me your work to find that variance and make sure you show me that last step to get that standard deviation by square rooting that variance. Because this is really how much the data varies by. We had to square it here to get rid of the negatives. To get that square back off, we had to square root it. That's really how much the data varies from each other. And now, let's go back to your Excel part of your assignment. Here's the 2 things we haven't learned, which I forgot to open up. Darn. Variance and standard deviation using Excel. So, hang on. Let me go back here for a second. Let me find it. There it is. Alright, so here's an example. Here's a set of data. How many? 1, 2, 3, 4, 5 of them right there. Here's the variance. The Excel function to find the variance of data is VAR. It's that easy. So equals VAR, parentheses, C11 dot dot, C15 parentheses. That's where this data is right up here above. So the variance for that data is 68. Now, you may want to do the square root of 68 by we haven't learned the Excel function for square root, but if you already know it, you probably want to do it to find the standard deviation, but don't. The Excel part of the assignment is you giving me the Excel functions you're learning right now, which are VAR, and show me you can use STDEV, standard deviation, STDEV. So if you can see here, it says equals STDEV parentheses C11 dot dot C15 parentheses. It's calculating that standard deviation of that data itself. It's not looking at the variance you just calculated square root it. It's calculating itself. So please use these functions to show me you can use them. Even though I know you can say, oh, find the square root of the variance, but don't do it. Here it is again, just so you can see it twice. This time it's the data in column E. E11 through E15. VAR, so the variance of this data up above is 21.5. And the standard deviation, STDEV, E11 through E15, is 4.636809. If I were rounding that to 4 digits, what would be the last digit on the right? Let me repeat that. If I were rounding this to 4 digits, what would be the last digit on the right?
8.
8. Very good, because the next digit after that's a 0. So you'd leave it at an 8, that 4th digit over. Don't go less than 4 digits. We gotta get in that habit to prepare for later weeks. All right, so now, let's see, we learned everything but correlation, I think. Hang on, I forgot to put this in here. Variance and ST, standard D,
EV.
thank you. Standard deviation. All right. How are we doing on time? We're rolling. All right, now, where are we? That was it. We were going to correlation, right? Correlation, we're back on track. Added all that out. Correlation. Oh, gotta get back here. Hang on. Hang on. Correlation. What I want you to understand about correlation, by the way, how it's calculated, it's looking at C11 through C15, which is this first set of data. Let me get my pointer there if I can see it. 6, 11, 15. And then it's also looking at the data at E11 through E15, which is right here, this data, and it's determining if somehow or another these two sets of data have are reacting to each other or correlated to each other in some way. So here's what I want you to focus on, though, is the meaning behind the correlation number. So let me start by saying the correlation is somewhere between -1 and +1, and it's point something. In this case, this one's 0.6930. But it could have been, I'm just going to throw some out there, negative 0.69. It could have been a positive 0.876. It could have been negative 0.21. There's any number you can think of between -1 and +1, point something, could be the correlation. But here's the meaning. This is what I should have up here, is that, I'm trying to figure out where to fit this. We're done with all this, right? All right, here we go. If the correlation, whether it's positive or negative, if it's close to 0, like maybe from there to 0.25, that is called low or slight, or what's another word for low? Low correlation. Very little correlation. Now that's from 0 to positive 0.25 and from 0 to negative 0.25. That whole range close to 0 is trying to tell you there's very little correlation. Now if the number's negative, it means there's a negative correlation between the numbers. And if the correlation number's positive, it means there's a positive correlation. Positive correlation means as one set of data is getting larger, the other set of data is going the same direction, also larger. Or as one set of data is getting smaller, the other set of data is also getting smaller, the same direction. That's a positive correlation. A negative correlation means as one set of data is going one direction, the other set's going the opposite direction. So if one set of data is going up, the other set's going down. If the first set's going down, the other's going up. Opposite directions creates a negative correlation. Positive correlation means they're going in the same direction, the data is. So as you can see, look at the X, 6, 11, 15, 21, 27. Y, as it lines up per period. The first period has a 6, just like X. The second period has a 9. The next one has a 6, the next one's 17, 12. They're both kind of increasing as each period goes by. Not necessarily a straight line increase, but they're both getting larger. That's why we have a positive correlation. And if that correlation number were somewhere around positive or negative, I'll put this plus or minus 0.25 between there and 0, it's like very little to no correlation. Let's go from positive negative 0.25 to positive negative 0.75. That is a mid, or sometimes called average correlation. In the middle, close to 0.5 and negative 0.5, right in the middle there, between 0 and 1 and 0 and negative 1, those are called average correlation. Now, anything above 0.75, that's called high correlation. Negative 0.8, negative 0.9, positive 0.9, positive 0.8, high correlation. Strong, be a good word. Let me put strong. Strong correlation, that's a good word. So, if you have this question on a quiz, or on your homework, I'm giving you a correlation number, and I'm asking you to describe it. You have to tell me whether that correlation is strong, average, or little or low, positive or negative type correlation. Let me start with, I see negative 0.69. How would you describe that? Someone volunteer. Get my attention. Average what? What kind of average correlation though? No, negative. Negative 0.69. Average negative correlation on that one. Let's go with positive 0.86. How would you describe that? Strong, positive correlation. Very good. Negative 0.21. Weak or low. What do you want to call that? Weak, low. That's another good word, by the way. Let me put weak here. I'll accept any of these words that represent weak, low, the what kind of correlation? Negative. Negative correlation. Weak, low, negative correlation was 0.21. Is that good? Is that all the numbers we got? What do we got here? 0.69. That's a positive 0.69. How would you describe the correlation on these two data on the spreadsheet?
Positive average.
Average positive correlation. Very good, because it was closer to 0.5 than it was above 0.75. Everybody see how to describe the correlation? Okay, you're done with this week's stuff. So, you want to ready for the in-class? I'm going to pass these back, so listen for your name while you're working on the in-class, so I can pass these back. And I think that's it. Let me look at my thing here. Credit